Hello, everyone. Hope you're all doing well and welcome to this webinar today. Depending on where you're from, I would like to wish you all a very good morning, good afternoon, or good evening. And as you can see on the slide over here, this is Manage Agent Shield 2021. It's a cybersecurity and IAM webinar series. We are on day one today. In fact, we'll be covering 6 different topics each week starting today. So today is October 19th. We are on topic 1, which is going to be on machine learning and artificial intelligence in SIEM. We go on next week on October 26th, where we tackle topic number 2, that is on SIEM. Zero trust is the third topic. Password security is topic number 4. Identity and access management will be covered on as topic 5. That would be on November 16th. And finally, on November 23rd, we'll cover topic number 6, that is on cloud security. So that's what we have planned for you guys. The times at which all of these webinars will take place is this right here. It's going to take place at 10 a.m. Eastern, that is 2 p.m. GMT or 3 p.m. BST. So welcome once again to Cybersecurity and IAM webinar series. The objective of today's talk is to give you an in-depth look at how machine learning and artificial intelligence can be used for cybersecurity defense, that is in SIEM. Hopefully, you'll get a clear understanding of what machine learning is, how it can be applied to solve real-life security challenges, and why it's so important in this era of sophisticated attackers. So with that said, let me quickly introduce myself. My name is Ram Vaidyanathan, and I'm a cybersecurity specialist at ManageEngine. As part of my role, I get to learn about the different ways in which attackers try to steal data and take down organizations, and also what organizations can do to detect and respond to such threats. One of my most favorite things to do is to talk about machine learning and how it can be used as an effective mode of defense against cyber attacks. One more thing that I'd like to do in my free time is actually ethical hacking. That is something that I've gotten into recently, and that is something that I find really, really interesting. If you want to get in touch with me about anything once this webinar gets over, that's absolutely fine. I would love to hear from you. My email address is ram.v@manageengine.com. Before we go ahead, I would just like to get a few confirmations from people that everything is fine. You can hear me loud and clear and that my slides are also visible on your screen. So if you can just confirm this to me over chat, that would be great, and we can get started. Again, I'm just looking for a few confirmations from people that everything is fine and we can get started. And I seem to have got a lot of responses. Thank you so much, Raymond. Thank you, Ilya. Thank you, Gareth. Thank you all so very much. Thank you, Mark. Thank you so much for those confirmations. All right, great. So here's the agenda for today. In the next 45 minutes or so, you'll hear about what artificial intelligence is and what it is not. We'll examine the differences between AI, machine learning, and deep learning, and how the three can be used in cybersecurity. We'll then talk about supervised and unsupervised learning and the pros and cons of using each for specific security use cases. We'll then step into a practical world and look at examples of time, count, and pattern anomalies of entities in a network. Risk scoring is another major thing that you'll hear about today. What exactly is risk scoring? And how can you customize these risk scores? And how can you use peer grouping to calculate risk? So that's something that we'll be looking at. Now, it's also important for security analysts to build a timeline or a sequence of anomalies that led to an incident. You've got to know what led to an incident, right? You've got to know exactly what was the sequence of events that led to it finally being detected as an incident. So we're going to discuss that next. And then we'll talk about incident management with anomalies and end it all with a real-life example of a cyber attack. So that's what we'll do today, and that's why you need to stay with me for this webinar. Now, before we get started with things and discussing the topic itself, I would like you to imagine a situation with me. Imagine a scenario where a healthcare organization is working on some breakthrough research to find a vaccine for a completely new type of virus. Let's also imagine that an employee of this company is bribed by a competing organization to steal data about all the research and hand it over to them. So over time, this employee who has now gone rogue, this employee starts stealing the data. And since they are trusted within the company, nobody suspects anything. This results in the company losing out on its business and market share. This is a very grave situation, and it should have never happened. I mean, think about it. Data is the most important asset, and it should never be stolen from any company. In recent years, we have seen quite a lot of insider attacks take place, similar to the example we just went over right now. Likewise, we also have external attackers making use of sophisticated methods to take down organizations. Nowadays, things like living off the land attacks and things like an attacker coming onto the network and deleting their footprints, so to speak, so that the organization cannot detect them. These are very, very common. So you've got to have some sort of a mechanism in place, some sort of a sophisticated mechanism in place, and the right defenses in place so that you can track all the anomalous activities. Working with just the rule-based detection systems that track activities that a security analyst is particularly looking for gives one line of defense, no doubt about it. However, in addition to that, companies need a mechanism to track anomalies in the network. Now, in our example here, there was no way that a pure rules-based system could have detected that the employee was stealing data from their own employer. So how do you track anomalies in the network? Well, you've got to use artificial intelligence, machine learning, and deep learning to do that. So first up, let's talk about artificial intelligence, machine learning, and deep learning. Many times, these three terms are used interchangeably, but that is actually not accurate. There is a clear difference between the three, and cybersecurity analysts need to understand this difference so that they can use the right technology at the right place and also know what technique is being used for detection. Artificial intelligence is a general term that denotes any activity by a computer that mimics human behavior. It is all about using technology to make a machine think, learn, adapt, and reason like a human. Machine learning, on the other hand, is a way to implement artificial intelligence for practical purposes. It is all about creating software that has the ability to learn. Actually, let me put it a little differently. It is not about creating a software that works based on rules that are explicitly programmed, but software that is adaptive, learns, and becomes better with experience. Multiple things can be done within the software algorithms to make it a more accurate machine learning model. So that is machine learning. And then you've got deep learning. This is a specific form of machine learning. Here we are talking about artificial neural networks that imitate a human brain. In traditional ML, the human is still programming the machine to make it learn with experience. So the learning happens to be very linear. In deep learning, the machine learning pretty much learns without human intervention. It can analyze really huge amounts of data that is unstructured and unlabeled and uses its neural network to gain context. In this session, I will mainly be talking about how machine learning can be used in cybersecurity. Because as an industry, that's where we are. A lot of the vendors out there are using machine learning for cybersecurity defense. And that's what we'll focus on in this particular webinar. By the way, if you have any questions during the course of this webinar as we go along, please do send those questions using chat or using the Q&A tab. The Q&A tab is always going to be better. That will make sure that I don't miss any of your questions. So by all means, please keep sending me your questions, and I'll take them at the end of the webinar. Okay, so machine learning in cybersecurity. Now, it turns out that there are three main techniques when implementing machine learning for security. And these are supervised learning, unsupervised learning, and semi-supervised learning. In supervised machine learning, a human basically feeds both the input and the output to the machine. Now, they do it enough times, and the machine is able to learn a pattern. The input would be the samples that are fed into the learning model, and the output would be the classifiers or labels. A very simple example, let's say that you have a very long list of executable files or network data. So those would be your samples. And then you could label these samples as 0 or 1. So you have your network data, you're labeling it as 0 or 1. So 0 stands for malware and 1 stands for something that is safe. Over time, The system is going to learn the patterns of files that are malware and patterns of files that are actually safe. It can then make a prediction about a new file that has to be analyzed. Basically, what we are doing is creating a fully labeled data set and then finding some function that relates the input and the output. So this flowchart here explains this concept pretty well. You have data that you need to divide into your training model, and then you've basically got it divided into training data and your test data. And then using the training data, we're going to create a training model that will help us make a prediction. On the test data, we'll use the training model to make a prediction and then check if the prediction is actually true. In this way, we can actually improve the machine learning model over time. In a security incident, the system is going to make a prediction about an entity's behavior. And then ideally, it's got to check with the security analyst whether it's really an anomaly. The analyst will provide feedback, the system will learn more, and it will use this learning for the next time. So that's supervised learning. In unsupervised machine learning, there are only inputs and no outputs. So how does this work? Well, it's up to the system to discover patterns in the data. Once the patterns are discovered, they can then be shown to the security analyst so that corrective action may be taken. In unsupervised learning, at the very beginning, there are no right or wrong answers. The system is only trying to look at the data and make sense of what it says. One of the main ways to implement unsupervised learning is through the use of clustering algorithms. There is a large amount of data, and the system tries to create clusters or groups of entities that exhibit similar behavior. So on this graph here, you can see cluster 1. This represents one cluster that exhibits very similar behavior. Cluster 2 does the same. This is another set of data that exhibits very, very similar behavior. And so is the case with cluster 3. So what is being done here is we are arranging all of the data in a vector space model. And we are trying to find clusters that exhibit similar behavior. Now, this flowchart here explains the concept very, very well. Data comes in, it's transformed into clustered data, and then we need to evaluate our prediction. In cybersecurity, users who log onto a network between specific time ranges can be part of a cluster. Users who access certain servers can be part of yet another cluster. Servers that are accessed at certain times can be part of yet another cluster. So I'm just giving you 3 examples here. So this is about unsupervised machine learning. And then you've got semi-supervised machine learning. This is also called reinforced learning, where some of the data is labeled and some of the data is not labeled. And in my opinion, this is the way to go. This is actually the best way to go. This gives security analysts the option to teach the system about threats that are unique to their network and their business environment. And at the same time, it also uses unsupervised learning to give unknown information about the data. It can help reduce a lot of the false positives. So in semi-supervised learning, what we are actually doing is we are using parts of supervised learning and we are using parts of unsupervised learning. And using the two together can help a security analyst analyze raw data, glean information, acquire knowledge, build insight, and finally gain wisdom. So this is what the security analyst can do. And this really should be our goal. By the way, in case you're interested, this is called the DIKIW model. This is the DIKIW pyramid, and it can be used in cybersecurity. But whatever model, whatever algorithm you use, whether it's supervised machine learning, unsupervised machine learning, or semi-supervised machine learning, whatever algorithm is being used, the organization must make sure that all the data gets collected from across the network. It is necessary to collect data from the network devices such as routers, switches, and firewalls. You should also collect data from network file shares, databases, and applications. You should also be able to collect data from Active Directory, from cloud infrastructures, and privileged access management systems. And then once all of the data is collected, it has to be analyzed and contextualized. So it's very, very critical to collect all sorts of data from across the network. Now let's talk about how the analysis and contextualization can actually take place and how anomalies can be detected. As you can see on this slide, there are three primary types of anomalies that your machine learning system has to detect. These are time, count, and pattern anomalies. To find out what's anomalous, we first need to calculate a baseline of expected activity for every user and entity in the network. With time anomalies, we are asking questions such as, did a user log on at a time that fell out of their expected range? For example, there could be a user called Steve. So that's the example I'm going to go over in this slide here. There could be a user called Steve who is expected to log on between these times here, between 2 and 2:15 p.m. But they are showing a log on at 1 p.m. or at 1 a.m. Sorry. So is this a case of some sort of a malicious activity? So you can see that their expected log on time falls between 2 and 2:15 p.m. But what is obtained is an actual activity between 1 and 1:15 a.m. In fact, they've shown a log on at exactly 1 a.m. and that is a time anomaly. Next up, we have what's called count anomalies. With count anomalies, we are asking questions such as, are software and services being installed on hosts way too many times during a given time period? Here is an example in front of you. We see that there is this software from this particular vendor being installed on this host by this user called Martin 250 times. What is expected is only 7 such activities. And this is why this is a big, big anomaly. Is this a case of an insider attack? So this is the second type of anomaly. It's called count anomalies. With pattern anomalies, as the name suggests, we are looking for unusual patterns of events. Also, here we are not looking at hosts, users, and time in isolation. That's why it's called a pattern anomaly. So just take a look at this example. So here we've got this software installation taking place at this particular time at 7:07 p.m. The activity is being done by this user called Martin on this particular host. The pattern that is being analyzed here is this right here. It's hostname, username, time. The hostname and the username part of the pattern seems to be absolutely fine. Take a look at this. This is what is obtained. The hostname and the username part of the pattern seems to be absolutely fine. However, there is a deviation when it comes to the time of the activity. So what is expected is an activity during these time buckets. So if the activity was done between 7 and 8 a.m. or between 5 and 6 a.m., that would have been absolutely fine. But what is actually happening is an activity between 7 and 8 p.m. In fact, the activity happened at 7:07 p.m. and that is being tracked as a pattern anomaly. So yes, these are the 3 different types of anomalies. From here, the security analyst should be able to pivot and see exactly why any of these were actually anomalies. What was the underlying data that led to this being detected as an anomaly? Security analysts should not have to just rely on analytics black box and be in the dark about what goes on in the backend. They should be able to clearly see how far the observed values are from the expected values so that they can understand the risk level and the gravity of the situation. This is called anomaly visualization. And then comes, take a look at this here, peer grouping. This is very critical when using machine learning to detect anomalies in a network. Sometime back, when we spoke about clustering in unsupervised learning, we said that the clustering algorithms find clusters of expected activity for each user and entity so that their observed values can be compared to these clusters, right? With peer group analysis, we go several steps deeper, and you can see that on this slide. So what are we doing here? We analyze how an entity or a user behaves in comparison to other entities or users in a network over time. This will be useful for cases where an event may be anomalous considering the past behavior of a specific user, but may not be anomalous considering the normal behavior of his or her peers. So initially, peer groups are identified and entities and users are put into different peer groups based on the behavior that they have exhibited over time. A particular user or entity can belong to multiple peer groups as well. So let me give you a practical example. Let's say that a particular user is under investigation in a network. They have done a lot of anomalous activities over time. And this particular user happens to belong to the accounting department. Now, it would make sense for security analysts to put this user as part of a larger cluster, as part of a larger peer group of accountants. Because the reasoning here is that accountants are supposed to behave in a similar way. So if you compare this accountant's behavior to someone belonging to the marketing department, it may not make all that much sense, because marketing folks are expected to behave differently from an accountant. But if you were to compare this accountant's behavior to other users who belong to the peer group called accountants, you might be able to get a lot of actionable insight. So is this accountant behaving in a way that is very deviant from the way that other accountants are behaving in the network? If that is the case, there is cause for concern, right? So that is how a peer group analysis is going to help you. And machine learning is going to help you with that, right? Your machine learning algorithm has got to have a way to build all of these peer groups automatically, but just by looking at the behavior of different users. And one of the ways to actually implement peer grouping in machine learning in a cybersecurity solution is through an algorithm called ConStream, which we'll go over right now. Take a look at this. This is the ConStream algorithm. So what happens here is that when data is received as a stream, it is possible that the data distribution may vary over time. So you can have clusters that are currently present in the data, but maybe inactive at a future time. And there may be a new clusters created as the data distribution changes. When the data distribution changes, it makes the already learned model obsolete, and something called a concept drift happens. ConStream handles concept drift in a very neat way. If an incoming data point doesn't fit into any of the existing clusters, a new cluster is created with this data point. Now, this new cluster could represent an outlier or a trend setter. If no more points fall into the newly created cluster in the future, then it is an outlier. However, if other points begin to fall into this cluster, it becomes a trend setter. When clusters remain inactive over an extended period, basically by that I mean no points are added in that time period, then the cluster is removed from the list of existing clusters, and this is called cluster death. Outliers can also undergo cluster death. Since the data distribution could be changed with time, recent points are given more weightage. The algorithm goes over each point only once, and thus it's fast enough to be used in a streaming setup. So this is how we actually implement clustering and peer group analysis in a lot of SIEM solutions, including ours, which is called Log360. The next thing that we can talk about are risk scores. At the end of the day, security analysts need something tangible to understand the measure of risk that a user or entity poses to the organization. And that is what risk scoring is all about. There are multiple ways to calculate risk scores, but one effective way could be to have a risk score for every user and entity that falls anywhere between 1 and 100. A risk score will enable an analyst to prioritize threats and decide what issue needs to be looked at first. To calculate risk, several actions need to be looked at closely for every user and entity. For example, there can be a separate risk score for each of insider threats, account compromise, data exfiltration, and logon anomalies. So you can have an overall risk score, but then you can divide that risk into 4 different sub-risks called insider threats, account compromise, data exfiltration, and logon anomalies. And then building upon these risk scores, we can also have an overall risk score, right? So that's what I said. So now let's go over some examples of activities that should be considered when looking at insider threats, account compromise, data exfiltration, and logon anomalies. Now, these are not an exhaustive list, and they are not also mutually exclusive. However, they will give you a clear idea as to how you can go about doing this. For insider threats, an analyst can look at things such as data deletions across databases and files, abnormal file permission changes on hosts, unusual volume of user management activity, and abnormal EXEs that are run on host. So these are likely anomalous activities that are indicative of insider threats. For account compromise, we need to consider log-on failures, multiple system file changes, even logs being cleared unusually, and so on. Then you have data exfiltration. So here you probably need to look at abnormal software installations, data hoarding activities, abnormal file downloads, and abnormal file creates in the network. And then for log-on anomalies, you may need to consider log-on failure anomalies and log-on success anomalies. And then for each of these possible anomalous activities, you need to give a weightage and a decay factor. A weightage is given to quantify the importance of a particular anomalous activity to the risk score. The higher the weightage, the higher the impact on the risk score. A decay factor is a metric that will reduce the dynamic risk score over time. The higher the decay factor, the higher the rate of reduction. For example, a decay factor of 0 will not reduce the risk score over time, but a decay factor of 100 will quickly reduce the risk score to 0. So we have looked at risk scores for each anomalous activity, and then we have looked at how we can use that risk score in the overall risk score calculation as well. So we have these sub risks, and we are putting all of these together to calculate the overall risk score as well. So going on from there, let's talk about customizing risk scores. Now, this is going to be a very, very critical capability to have in your security analytics solution. It's very, very critical because think about it. Every organization is unique, and the way that one organization looks at risk scoring is going to be very, very different from the way that a different organization may look at risk scoring, right? What you may consider anomalous, another organization may not consider anomalous. What you may consider to be highly risky, and another organization may consider to be less risky. So a security analyst needs to have the flexibility to actually customize risk scores. They need to have the flexibility to assign weightages and time decay factors. So let me show this to you right now, because seeing is believing. Let me quickly show this to you. Let me quickly jump onto Manage Engine Log360. And this is in fact Log360 UEBA. This is the anomaly detection module of Log360. And let me show this to you right now. This is going to be a very, very critical capability to have in any security analytics solution. I think I'm having some technical difficulties in terms of connecting to the server. So we'll try and get back to this in some time. Let me quickly go back into the presentation. So the point that I'm trying to make here is that the security analyst will first need to decide what anomalous activities actually constitute a particular sub-risk. So they will have the flexibility to say that for insider threats, here is a list of anomalous activities that can be associated with insider threats. For data exfiltration, here is a list of anomalous activities that can be associated with data exfiltration. So that flexibility should be there. And then also the importance that they need to give to that particular anomalous activity. So they will have to have this flexibility to edit the weightage and the time decay factor as well. That is the way that you can actually customize the risk score, because every organization is unique. Then building a timeline of anomalies. Again, a very, very critical capability to have because this is going to give you the full context of a cyber attack. It will let you know and understand the sequence of steps that were followed before an attack took place. This information has to be available to the security analyst as they build evidence for an attack. Along with building the evidence, they'll also be able to see how each anomalous activity contributed to the overall risk score. For example, let's say that a particular user called Steve has the highest risk score of 85 in the entire network. On a dashboard, first of all, a security analyst needs to be able to see that. They need to be able to see that Steve is the user with the highest risk score of 85. From there, they should be able to build a timeline for Steve that led to his risk score being a relatively high 85. So here on the slide, you get to see an example of the kind of activities Steve could have done. He first had multiple successful logon attempts. Take a look at this. In fact, he had 102 such events when the threshold was just 14. This was followed by 99 file permission changes when the threshold is just 3. He then went on to perform 80 system file changes and numerous file modifications. We see that what is expected for Steve is just 2. The threshold here is just 2, right? So multiple files were modified by the user. Now, as a security analyst, when you look through this timeline and you put together what really happened, you can also go one step deeper, right? For example, you've got all of these different file modifications here, right? This one here, you've got to be able to see what objects were the targets of the potential attacker. So you've got to be able to click on something like this, and you've got to be able to see what those multiple files were that were modified by Steve. So that is going to give you much more context, right? That's going to tell you exactly all the changes that were made by this potentially malicious user called Steve. Then adding anomalies into an incident. This is going to be, again, a very, very critical capability to have. If you're using your machine learning algorithms to just detect anomalies across users and entities, that may generate a lot of alarms. I mean, please don't misunderstand this. There is value in looking at users and entities and the risk that they pose. However, from a response point of view, it's imperative that security analysts classify multiple anomalies as belonging to one incident. This can be done in 3 different ways. The analyst can manually add anomalies together as incidents. That's the easiest way to do things. This is going to rely on the analyst's intelligence to put together different anomalies and see them as part of a larger incident. That is the first way. The second way to add anomalies to an incident is through the use of incident template rules. This again requires intervention from the analyst, but it automates the process somewhat. The analyst creates a rule for an incident. They specify the criteria for incident creation, and all the anomalies that conform to that criteria will be automatically put into that incident. The third way, and this is the most innovative way, is to use machine learning. To create incidents would be, basically very hard, right? You're still basically asking the security analyst to go in and manually add them to a particular incident. But what if you could actually use machine learning and let the machine create incidents all by itself using machine learning algorithms? So you heard me right. Not only are the anomalies detected through ML, but here we are saying that incidents are built using machine learning. Semi-supervised machine learning can be used effectively here. So the system can build incidents, and then these can be shown to the security analyst, who then has to confirm that this is really an incident. This could really take things to the next level. So all that the security analyst is doing with machine learning is that they are validating that whatever the machine has learned is in fact true. The machine is going to show them all the incidents. It's going to put all of the anomalies together as one incident, and it's going to show these things to the analyst, and the analyst will then validate this, whether it's true or not. In case they validated this as true, this is going to be reinforced into the machine, and it's going to become that much better for the next time. And in case the analyst says that these are in fact not, to be considered as one particular incident, the machine will also learn from that, and it will become better with experience. Building your own anomaly models. Again, very, very critical capability to have in your security analytics solution. Again, this goes back to the fact that every organization is different, and you can't always rely on the machine learning model that is provided out of the box by your vendor. As a security analyst, you may want to build your own anomaly models. You may want to build your own anomaly detection capabilities. So that is what anomaly modeling is all about. For example, in Log360 UEBA, what we give with time anomalies is a 15-minute deviation limit. So all the anomalies that are detected within 15 minutes are going to be looked at very, very closely. And anything that happens outside that 15-minute deviation limit can be considered an anomaly, right? So that is something that we build out of the box. But if your organization is different and you want to work with a 1 hour deviation limit, you can do that. If you want to work with a 2 hour deviation limit, that you can do that. So you can build your own anomaly models in addition to what you have out of the box. Likewise, you can also decide your aggregation limits for count anomalies, right? In Log360 UEBA, what we give is a 1 hour aggregation limit. So we look at all the count of anomalies that have happened for 60 minutes. And then we say that anything that deviates out of the normal beyond those, the number that is expected for those 60 minutes, that is going to be considered an anomaly. But your organization could be different. In fact, you could be an organization that wants to look at a 12-hour deviation limit, or sorry, an aggregation limit when it comes to count anomalies. You can do that. You can build that into your anomaly model. Again, a very, very critical capability to have in your security analytics solution. Now let's look at a case, a use case. We'll go over an example of a data exfiltration attempt over here. So we're trying to put everything that we learned together over here. So here what we have is an external attacker. And on day one, they send a legitimate looking phishing email with a malicious attachment to a front-end employee named Bob. The email contains a doc file that Bob clicks on, and without Bob's knowledge, malware starts being downloaded in the backend. In this way, the attacker gets an initial foothold into the network and also compromises Bob's credentials. So that is what is happening. Then the attacker connects to the network from a remote location using Bob's credentials. This will trigger a pattern anomaly and increase the risk score associated with an account compromise. That is what is happening on day 7 here. Then the attack actually lays low for a few days. This is something that a lot of attackers do. They don't want to kind of set off alarms right then and there. They will actually want to stay safe, play it safe. That is what our attacker is doing in this particular example. Between day 7 and day 10, they're actually lying low. And then on day 10, take a look at this. The data exfiltration, the risk of a data exfiltration is increased, right? So basically what we are saying is with your anomaly model, you want to give risk scores to successive anomalies that are being detected in the network. And as soon as your risk score goes beyond a certain threshold, let's say that you have decided that 50 is the risk score that you want to work with, and anything beyond 50, you want to be alerted about it, you can be alerted about it. And this way, you're not waiting for the attack to completely unfold. You get to see that this particular scenario, it has a risk score of 50. This is something that is highly risky, and you can come in and you can take action right then and there. So here are the next steps. So let me quickly show this page to you. If you want to learn more about anomaly detection, you can visit this page. There's a lot more resources as well. So I'm just going to put this on chat, and you can access this whenever conveniences permit. So there you go. You can access this. And I also want to bring your attention to a lot of these year-end offers that we are running. So we'll be emailing those to you as well. So about all of those year-end offers, but these year-end offers are for just the US and the UK. So in case you're interested in getting your hands on Log360 UEBA, please let us know. These are some really special offers that we are running for the year end. Great. So that brings me to the end of this particular webinar. I do have a couple of polls to run right now. So let me quickly run those polls. So if you can take a few moments to answer these questions that you see on your screen for me, that'll be really, really great. I see a lot of answers coming through, so we'll just give it another 10 to 15 more seconds. All right, thank you so much for those responses. Let me quickly end this poll. And I have one more poll to run, and this is all about the session feedback. So if you have any feedback about how this session went for you today, that'll be really great. And just as you're answering that, let me take a moment to thank you all for being a part of this webinar. I see that a lot of people have asked questions using the Q&A tab. So I'll still be online for the next 10 minutes, taking all of those questions over chat. Thank you all so very much, and we hope to see you again soon for part 2 of this webinar series. So there's a question from Arvind who says that he wants to see Log360 UEBA in action. Thank you, Arvind, for that question. We were trying to go over the demo during the presentation itself. For some reason, I was having some connectivity issues, but here it is right now. This is Log360 UEBA. And as I said during the session, there are three main things that you want to look at, three main types of anomalies that you want to look at. That would be your count, time, and pattern anomalies. So if you go over to anomaly reports, this is where the three types of anomalies will be visible for you. We'll take a very, very simple example based on logons, and not just logons. It's going to be based on your Windows devices, and these are your time-based anomalies. Now, if you were to look at this particular report, just take a look at this. You have this user called UEBA user 1, and they are showing a logon at 4:15 p.m. when what is expected is a logon between 4 and 4:15 a.m. So this happens to be a huge deviation from what is expected from this particular user, right? So it's a very, very simple example of a time-based logon anomaly. From here, what the security analyst needs to be able to do is they need to do something called anomaly visualization. They can go into view details and they can exactly see how far the expected value is from the obtained value. So this is going to be a visual representation for them to see how risky this particular user actually is. So this is an example of a time anomaly. Likewise, you can also have pattern and count anomalies, right? So we'll take a look at a count anomaly first. So let's go into count anomalies based on software installations. So just go into count based here. The criteria is still going to be users. So in a solution like Log360 UEBA, you can pivot based on users or hosts. It's completely up to you. Let's just keep it as users. Now, if you take a look at this report, you see that there is a software installation, right? This is the software that's being installed. It belongs to this particular vendor. The activity is happening on this host. This is the user that is doing this particular activity. The number of times it's happening is 250 times, when in fact the threshold is just 7 such events, right? In Log360 UEBA, what we use is a 1 hour aggregation limit. So we are looking at time anomalies based on the number of activities that have happened between 60 minutes, between buckets of 60 minutes each. So this is where the anomaly modeling capability is going to become very critical for you. If your organization is different and if you want to aggregate across a larger time period, you can totally do that. You have that flexibility as well. But anyways, this is a count-based anomaly, right? 250 events that are obtained, when in fact what is expected is just 7. The third type of anomaly is the pattern-based anomaly, which you can look at over here. Take a look at this. So this is the pattern that is being analyzed. The host name, username, and time. This is the pattern that is being analyzed. And this part of the pattern, the host name and the username part of the pattern seems to be absolutely fine. But this part of the pattern, this is where the problem actually lies. The activity has happened between 7 and 8 p.m. when in fact what is expected is activity between these time buckets. So this happens to be a pattern anomaly. So with pattern anomaly, what we are saying is that it is not going to be adequate if a security analyst just looks at time and count anomalies. You've got to be able to put several different variables together and observe and make sure that a pattern is not anomalous. Many a time, if you just put 2 different variables together, that may or may not give you the complete picture. So it's always going to be important for you to put several different variables together. Here we have a pattern of length 3. So we're looking at 3 different variables, but you can have more complex patterns as well. It's very, very critical to look at patterns and make sure that nothing wrong is happening. All right. So this is the pattern anomaly. And every time an anomaly is detected, what is happening is that the risk score is going to be increased. So here is the user that is making these activities, right? This is the user that is doing all of these activities. Their risk score is going to be increased upward. Every time a new anomaly is being performed, a new anomalous activity is being performed by this user, their risk score is going to be increased, associated with that particular anomaly. And then if you go over to the dashboard, and then you go specifically into the user's dashboard, you'll be able to see all the anomalous activities performed by a particular user over time. So here you have this particular user called user 1. They have the highest risk score of 56 in the entire network, right? You can just click on that user, and then you get to see the risk score of this particular user. You get to see that they have an overall risk score of 56, and they have sub-risks over here as well. They have a sub-risk score insider threats of 69. And when it comes to compromised accounts, their risk score is 70. So they are a likely candidate for insider threat and compromised accounts. Not so much the data exfiltration. Now, if you scroll down, you actually get to see the entire timeline. You get to see all the anomalous activities performed by this particular user called user 1 over time, right? So this is how, as a security analyst, you get all of this empowering information, and you can get all of this actionable insight. So you get to see all the activities performed by user 1, and this is very, very telling, right? They had 204 events associated with multiple or associated with file modifications. Something very, very strange, you can then go in and take action. Right? And then when you go over to, let me quickly show this to you. Let me just show you how alerting works. If you go over to the alert tab, you can actually create an alert. Just go into manage profiles and add alert profile. You can set up an alert, right? All of this is going to be completely up to you. You can choose risk card, for example, and you can say that the threshold that you want to work with is 50. Anything over 50, you want to be alerted about it. So you can do that. Anytime a particular user's risk score or particular entity's risk score goes beyond this threshold value, you can get alerted about it in real time. So all that you need to do is get that email notification set up. You need to configure a mail server and you can get notified. So that's how the alerting actually works. Okay, so I have one more question from Makinur Rahman, and he asks, who will define the pattern and expected values and how? Can you please demonstrate that? Yes, definitely, Makinur. So that is where the anomaly modeling actually is going to become very, very important for you. Out of the box, we provide certain anomaly models for you. Like I said, when it comes to the time anomalies, we work with a 1 hour time deviation time limit. So we look at buckets of time, buckets of 60 minutes, right? So sorry, when it comes to the time anomalies, we are actually working with 15-minute buckets. So we're looking at 15-minute buckets. The 24-hour period in a particular day is divided into small 15-minute buckets. So 12 a.m. to 12:15 a.m. will be one time bucket. 12:15 a.m. to 12:30 a.m. will be another time bucket, and so on, right? And we are specifically looking for those anomalies or for those activities that fall outside that particular time bucket. So an activity that is expected to happen between 12 and 12:15 a.m., but if it happens beyond 12:15 a.m., that will be flagged as an anomaly, right? So that is what is happening with your time anomalies. With your count anomalies, we are looking at 1 hour aggregation limits. So again, this 24-hour period, we divide it into 24 different 1 hour buckets, and we are looking at aggregating all the activities that happen within each 1 hour time bucket. And in case an aggregate within a particular 1 hour bucket happens to be beyond what is expected in terms of an aggregate, that will be flagged as a count anomaly. When it comes to pattern anomaly, it is again something very, very similar. So let me quickly see if I can show this to you. If you go into configuration, you have something called anomaly modeling, right? And this is where you can actually create your own anomaly models, right? So instead of just going with what you have out of the box in Log360 UEBA, you can actually build your own anomaly models. You can select the source from which you want to bring in all of your input data. That can be done here once you give the anomaly name. And then you can actually set your anomaly parameters. So you can actually choose what kind of anomaly model that you want to build, and then you can do that. In case you want to know more about this, please let us know, and we'll be very, very happy to take you over a more full-fledged demo of how you can build all of these models. Okay, there's one more question from Raj Kamal, and he asks, this anomaly we need to pre-configure. See, that's the whole point of anomalies, right? Or anomaly detection. You don't have to really write any rules. We're actually relying on the machine learning model to learn by itself and understand what is normal and what is not normal for every user and entity in a network, right? So that's what we are trying to do over here. Now, there is something called a training period that every machine learning model usually goes with, and it is usually 2 weeks. So when you first deploy using an entity behavior analytics solution like Log360 UEBA, for the first 2 weeks, the results are not going to be very accurate because the model is still trying to come to terms with what is happening in the network. But give it some time, give it about 2 weeks, and what you're going to see is more accurate. Give it 1 month, and then probably it's got enough time on its hands and it's learned quite a lot about the network, and it's going to give you more accurate results. The point is, you're not trying to pre-configure anything here. You're trying to let the solution learn all by itself. But then, like I said, every company is different. So there is a little bit of flexibility that you can actually have. So that is where anomaly modeling, which I spoke about just now, is going to become very critical for you. Likewise, risk score customization as well. So if you go into risk score customization, this is something that you can configure. You can actually configure what constitutes insider threats, what actually constitutes data exfiltration, compromised accounts, and logon anomalies. So you can go in here, you can edit this, you can actually edit all the activities that are associated with data deletion, for example. We do provide this out of the box, but you do have the flexibility to edit this. You can actually go in very, very granularly and change the weights that you assign to each of these anomalous activities. You can change the decay factor. So all of these things can be configured. Okay, there's one more question. Raj Kamal says, only 3 anomalies we have. So Raj Kamal, yes, as of now, we are working with 3 different anomalies. We are working with time, count, and pattern anomalies. And when we look at patterns, right, we are not just looking at, pattern anomalies can actually encompass a lot of different variables as well, right? It is not just time and count or the username itself, right? It can be multiple things. It can be, for example, things like the domain controller or the domain name. It can be pretty much any kind of event that you want to have, that you want to bring into the anomaly detection platform. You can actually bring all of that in. So the pattern anomaly will actually cover a lot of the different use cases, the security use cases that you may face at your company. Apart from time, count, and pattern anomalies, anything we can customize. So yes, you can customize the risk score customization as well. So you can actually give all of these different weights and the decay factor. You can also specify what constitutes the different categories of anomalies that you have within the solution. So that level of customization is there. I'll also show you some level of customization when it comes to alerting. So if you go into alerts, let's go into manage profiles and add alert profile. So you can give the alert name and a description to describe what this alert is all about. You can also set the severity level. This is completely up to you, whether you want it as attention, trouble, or critical. Is the alert going to be based on a particular report? Is it going to be based on an entity, or is it going to be based on a risk card? If it's going to be based on a report, you can then go in and select the report, right? You can then go in here and you can actually select the report that you want to look at. So do you want to look at your network devices, your application sources, your firewall devices, or your cloud services? You can choose any of these. And then let's say that we want to look at our network devices and we want to look at the registry activities for our Windows network devices. You can choose the report source, right? So you can actually do that and go in over here and select it. And then you can select the entity. Are you looking at just users, or are you also looking at hosts? You can actually go in and you can choose both, or you can choose specific users and hosts for which you want to be alerted. So you can do all of that. And once that is done, you can go into advanced configuration here. You can set in a threshold. So perhaps you don't want to be alerted each and every time an anomaly is detected, right? So that may or may not be malicious. But let's say that a specific anomaly occurs and the same anomaly occurs 5 times in 10 minutes, right? Now, this is something very, very strange, right? You may want to be alerted whenever something like this happens, or you want to be alerted whenever, the anomaly happens during non-business hours. So you expect that these anomalies to happen during business hours, but you don't expect such activities to happen during non-business hours. You can do that during your advanced configuration. You can put that over here, and then you can save your changes, and you're going to be alerted for these configurations that you have set. Hope that answers your question, Raj Kamal. All right, great. Thank you so very much for being a part of this webinar. And if you have any further questions, I'll be very, very happy to hear from you. My name is Ram. My email address is ram.v@manageengine.com. You can send me an email at any time with any questions you have. You can also add me on LinkedIn. You can find me on LinkedIn through this name, Ram Vaidyanathan. So thank you all so very much. Until next time, please take care. Bye for now.